This is the Proteopedia page of green fluorescent protein in January 2026. You can see that there's an effort to make a new version of the Proteopedia program. Check back in a couple of months. I want to start with the history. So this is one of the most popular pages, and it's also one of the ones that is the oldest. So this is a revision history, and it was created by one of the co-founders of Proteopedia, Aaron Hodis, in March 2008, so 18 years ago. And it's going to go here. This was the state for a couple of months. And this is how it looked like back then. So green fluorescent protein is a beta-barrel protein, and in the inside, 3 amino acids get covalently modified to make this fluorophore, making it green. And it's been used in research. It's from jellyfish, but has a lot of, there's at least one Nobel Prize associated with it. So here's a interactive view of this, and there's another interactive view, and it turns out that most of the content was adapted from the Molecule of the Month made by David Gutzel. So if I go back to the history, the page was basically brought back to a replacement, and then Wayne Decatur worked on it. And now it has a table of contents and sort of the typical structure that many pages have, background structure here, and references. I'm going to move up a little bit in history. So from 2008, we'll go all the way to 2010. Edited by Carl Oberholzer. And some new pictures. There's talk of the chromophore. We have the chemistry here on the left side. And lots of browsers here, and this has changed. That's the one thing I want to show. If we go to the current page, so this is the current page, and it has this new slider here, which allows us to browse the text while keeping the interactive figure intact. Let me just give us a little bit more space here, so we can also see the caption. So right now this is a animated GIF to make it load faster, and now I'm actually getting the interactive figure, which has the advantage that you can rotate it yourself and hover over different aspects of it and see what we're looking at and measure distances and so on. So here's more about the background, and now we're getting into the place where we have green links. This is the default scene. Let's make sure that that's still in place. That restores the orientation and everything. And there's one scene that shows the secondary structure. So you can already see it's mostly beta strand. get this to load. And here, highlight of the water molecules that are found in the crystal structure. Let's see if I can go back here and see if that was a glitch. Or there we go. That's what I expected. So this is the secondary structure in the typical default color scheme that JMOL does, with these tan-like beta strands, and then the helices in purple and, I don't know, reddish. Okay, here's back to the water molecules, and there's one special alpha helix that's highlighted here that runs through the central axis of the beta barrel and has these three covalently modified side chains that then form the fluorescent molecule. You can see it's perpendicular to the symmetry axis, so it's different orientation, same figure. Here's an interactive element that shows that this is actually, right now it looks like there's a gap between the chromophore and the rest, but it's actually goes all the way through. So this creates the bond, so you can see that. Here's another view of the chromophore. And this top view also has some surfaces on them. I don't know what happened there. And we can see the detail of the structure here. This is not without the protein, so you can study this. And you can highlight, these are the atoms that used to be threonine. These are the atoms that used to be tyrosine, and these are the atoms that used to be the glycine. But there's this ring formation and other chemistry going on, some redox chemistry too. The details are shown here. And also, we're not showing double bonds right now, but in this scene, we are showing the double bonds, so you can see it's an extended conjugated system. And as I said, there's like 2 steps. Actually, there's 3 steps. There's a cyclization step, there's a dehydration and oxidation step to get the mature chromophore that actually fluoresces. Apart from the green links, there's also blue links in here. This one's broken, doesn't exist. So this is a view of the surrounding of the chromophore. The chromophore is in green. There's a bunch of water molecules. And then it goes through the different interactions. Polar interactions. A tyrosine that has an edge-phase interaction. And if you go fancy, it's harder to see, I think, but it's fancy. And there's an arginine that is hypothesized to act as a base by withdrawing electrons. So I don't know if that's a Lewis base or a base base, but it's a base. Of course, this text is written like a wiki, so it's been updated, as you can see from the history. And if there's any mistakes, then people will fix them if they find them over time. These are different mutants. So it's without the ends. It's not hard to see because we're switching orientations. Sorry about that. There's also an amino acid. they studied, what the function is. The last thing is about dimerization in multimers form. So here's one example of a crystal structure where you can see that it forms a tetramer. Here's a link that actually works within Proteopedia. There's other links that go outside of Proteopedia. Last part here is shows some 3D printed physical models. So 3D printing came about while Proteopedia existed. You can check when that was added to see when 3D printing of proteins became available to the larger public. Okay, and this is well referenced here. If you click here and want to know where it was referenced, then it goes back in the text, so that's nifty. And there's links out to other resources, and you can again see who has edited over the years. This one is a page that's special, that has a DOI, document identifier. You can find this and cite it. Here's the citation, because it has this document identifier. Okay, so that was green fluorescent protein. A little bit of the history, how the page come about, and a little bit of a walk through what the current page has to offer.